Welcome back, students. We have studied the laws of exponents, and we have also seen the questions based on laws of exponents in our previous class. In this class, we will see two more questions based on the laws of exponents. Question number 19 and question number 20. First of all, let us solve question number 20. After this, I will be able to remove this. So the question says x to the power a plus b and whole to the power 2, x to the power b plus c whole to the power 2, and x to the power c plus a whole to the power 2. It is divided by x to the power a, x to the power b, x to the power c whole raised to the power 4. And you have to prove this whole is equal to 1. So let us see. You have studied the property, the laws of exponents, a to the power m and that raised to the power n. Power of power gets multiplied, a to the power m n. We will apply this here and we get x to the power 2a plus b into x to the power 2b plus c into x to the power 2c plus a whole divided by. Now again, if you have ab to the power n, it becomes a to the power n and b to the power n, isn't it? So this power gets along with this one and this one also. So here we can write x to the power a and 4 will come along with it. A multiplied by 4, 4a. X to the power 4 multiplied by b, 4b. And x to the power c and multiplied by 4. X to the power c and that has a power of 4, it will be x to the power 4c. So we can write this. Next, this is you have a to the power something, suppose m, and again a to the power n, and both are having a multiplication in between, that is a to the power m into a to the power n. What it becomes? It becomes a to the power m plus n. Whenever bases are same, coefficients are different, coefficients are no matter whatever it is, if the bases are same, the exponents add up. So this will become a to the power m plus n. Here also you can see base is x and they are separated by the multiplication in between them. So exponents will add up, base remaining the same. So base will remain x, 2 into a plus b, 2a plus 2b, 2a plus 2b. This will add up, adding 2b plus c, that means adding 2b plus 2c. Again similarly, we get 2c plus 2a divided by. Here also base is same, so the powers will add up. It will become 4a plus 4b plus 4c. What do you get from here? X to the power 2a and 2a, 4a plus 2b plus 2b, 4b plus 2c plus 2c, 4c divided by x to the power 4a plus 4b plus 4c. Same thing are in the numerator and denominator. Anything divided by itself gives 1. if you have 2 and it is divided by 2, what do you get? You get 1. So in the numerator also 4 to the power 4a plus 4b plus 4c, and denominator also x to the power 4a plus 4b plus 4c. So the result will be 1. Both will cancel out each other and the answer you will get 1. So you started from LHS and you got the RHS as 2, and hence you have verified that this portion LHS equals to 1. Clear? After solving question number 20, let's see question number 19. In this question, you are given 9 to the power n into 3 to the power 2 into 3 to the power minus n by 2, and this whole has a power of minus 2 minus 27 to the power n divided by 3 to the power 3m into 2 to the power 3, and this is equal to 1 by 27. This you don't have to prove, this is given. What you have to prove is m minus n is equal to 1. Let us see, let us solve this, and we will arrive at m minus n equals to 1 if we take a right approach. In mathematics, taking right approach is very essential. So how you will approach for this question? See, this is given in terms of 3, this is in terms of 2, again in terms of 3, in terms of 3. So it's better if we convert this 9n to the power n and 27 to the power n. If we convert them also in the form of 3 to the power something, it will be easier for us. This will be your first approach to ask the question. So let us do 3 to the power 2 is 9. Now power of power will multiply minus n by 2 into minus 2. Minus 27 can be written as 3 3 is 9, 3 is 27, it is cube of 3, and this is 3 to the power 3m into 2 to the power 3. These are already written in the form of 3 and 2. You can write it as 3 to the power 3. Okay, so here you find 2 cancels 2, it becomes minus n into minus 1, it is plus n. So we have 3 to the power 2n into 3 to the power 2 into 3 to the power n minus 3 to the power 3n divided by 3 to the power 2m into 2 to the power 3, and that is equal to 1 by 3 to the power 3, isn't it? Now see, this is 3 to the power 3n. Here you get 3 to the power 2n and 3 to the power n. This will together form 3 to the power 3m. You can write 3 to the power 3n. What is left? 3 to the power 2 minus 3 to the power 3m divided by 3 to the power 2m into 2 to the power 3 equals to 1 by 3 to the power 3, isn't it? This you can write, this is 3m. So in this term and in this term, what is common between these two terms? 3 to the power n is common. Taking 3 to the power 3n as common, what is left? 3 to the power 2 minus 1. You can apply the distributive law and check whether you have done true or right or wrong. 3 to the power 3n into 3 to the power 2 this side minus 3 to the power n into 1, 3 to the power n, this side. So it is right. This is 3 to the power 2m into 2 to the power 3, and this is equal to 1 by 3 to the power 3. So from here you get 3 to the power 3m into 3 3s are 9 minus 1. What is it? 8 divided by 3 to the power 2m into 2 cube. 2 cube is 2 2 ja 4 2 ja 8 equals to 1 by 3 to the power 3. This 8 and 8 will cancel each other. Now whatever is left is in terms of 3 only. This you can write as 3 to the power 3n divided by 3 to the power 2n equals to 3 to the power minus 3, isn't it? Now you have studied that a to the power m divided by a to the power n, what it becomes? It becomes a to the power m minus n. When you are dividing two things and one has a base and in numerator and in the denominator also there is the same base, then powers subtract from each other. From the power of numerator, power of denominator is subtracted. So in the same way we will proceed here. 3 to the power 3n in the numerator and 3 to the power 2m in denominator. So it will be 3 to the power 3m minus 2m, and on the opposite side we have 3 to the power minus 3. So this was 3 to the power 3m. This is not 2. You can see from the question. In the denominator it was 3 to the power 3m into 2 to the power 3. 2 to the power 3, that is 8, got cancelled. In the denominator what is left? 3 to the power 3m. So 3 to the power 3n minus 3 to the power 3n minus 3m equals to 3 to the power minus 3. Now compare this. Compare these two. If I say 2 to the power 3, that means 8. If we want to express it in terms of 2 only, then the power will only be 3. It cannot be 4, it cannot be 5, it cannot be 1, it cannot be 2. So if base are remaining same, both values are same and base is same, the exponents must be same. Here both these values are same, their base is same, so the exponents also should be same. 3n minus 3m, this exponent should be equal to this exponent, correct? When you have 3n minus 3m equals to minus 3, you can take 3 common, it will be n minus m, and 3 common, it will be minus 1 over here. You can cancel out 3, or if you want you can transpose this to opposite sides. This is in multiplication, this will get itself into division, and 3 will be numerator, 3 will be denominator, they will cancel each other. In this way also you can crack it. So 3 gets cancelled by 3, what is left? What is left is n minus m equals to minus 1. But we have to prove what? M minus n, not n minus m. If I say 2 minus 3 equals to minus 1, it obviously means 3 minus 2 equals to 1. But how? You can multiply minus 1 in both sides. This will give you what? This will give you minus 2 plus 3 equals to 1. And minus 2 plus 3, you can rearrange it. Plus 3 minus 2 equals to 1. Similarly, we can multiply with minus 1 both the sides. There will be no effect in the equation. If it is 2 and it is 2, if you multiply it by 3, you multiply it also by 3, there is no effect, 6 equals to 6, then it is also correct. The problem is when you multiply it from 3 this side and 4 this side, this will not be equal. But multiplying it with equal number, there will be no effect in the truth of this equation. Equation will remain valid. So what do we find? We find n minus n plus m equals to 1. Rearrange this. M is in plus, n is in minus, and you have 1. This is what we were asked to find out. So in this way you can solve the questions of laws of exponents. Hope the laws of exponents is clear and you can crack or solve any questions from the laws of exponents. This is all about the number system. Your number system ends here. In the next class we will start from your chapter number 2, that is polynomials. There is one more doubt that might be creeping inside you, or if not right now, then after some time you might be having a confusion or doubt that if we have already a term fraction, then why are we using the term rational number? What is the difference? We can already use the word fraction. Why we are using rational number? Is there any difference between them? Yes, if there are two words, there has to be certain difference. A smile, and we have another word, laugh. Both are different. Even in walking or in looking, beep has a different meaning. Sight has a different meaning. Glare has a different meaning. Beep and sight, these are for looking. And stare, yes, stare has a different meaning. All these are used for looking, but they all have different meanings. So different words, different meanings are there. Similarly, fraction and rational numbers, they have different meaning. See, rational number you have already studied in the number system. What it is? It is in the form of P by Q, or P by Q, where P and Q are integers and Q is not equal to 0. However, fractions are in the form A by B, where A and B are whole numbers, and obviously B is not equal to 0 because division by 0 is not defined. Why division by 0 is not defined? We will study about it in later classes, in later video. Right now our focus is to see the difference between rational number and fraction. So if I say a number 7 by 11, it satisfies the condition of fraction. A and B both are whole numbers, and the denominator is not equal to 0. It is a fraction. Is it a rational number? Yes. It is in the form P by Q. P and Q both are integers. Q is not equal to 0. So it is also a rational number. So this is a fraction also and a rational number also. But what about if I ask you 7.5 by 11? Have you ever studied a whole number which is 7.5? No. 7.5 is an integer but not a whole number. So for being a fraction, P and Q, that is numerator and denominator, both should be a whole number. 7.5 is not a whole number. This cannot be a fraction. This is a rational number. So all the fractions are rational numbers, but all the rational numbers are not, they are not fractions. All the fractions are rational numbers, but all the rational numbers are not fractions. So that is the difference between a rational number and a fraction. So this is for today's class. In the next class we will start with a new chapter, polynomials. Take care.